My Valentine's Day fun continues. I've made video 10.1, 10.2, and now 10.3. We're going to apply properties of chords. We are going to use relationships of arcs and chords in a circle. Tell whether the segment is best described as a radius, a chord, or a diameter of circle C. DC, that would be a radius. B to D would best be described as a diameter. D to E would best be described as a chord. And A to E would best be described as a chord. And let's solve these problems. If I subtract 8x from both sides, I get negative 4x equals negative 12, so x equals 3. And on the next problem, I'm going to subtract 3x from both sides. 2 equals 3x minus 4. Add 4 to both sides. 6 equals 3x. X equals 2. Recall that a chord is a segment with endpoints on a circle. Because its endpoints lie on the circle, any chord divides a circle into two arcs, circles. Any other chord divides a circle into a minor arc and a major arc. In the same circle or in congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. That means arc AB will be congruent to arc CD if and only if AB is congruent to CD. Here, AB is marked congruent to CD, so these arcs are congruent. So we are going to use congruent chords to find an arc measure. In the diagram, circle P is congruent to circle Q. This radius is equal to this radius. FG, we're being told, is congruent to JK. And the measure of arc JK is 80 degrees. Find FG. Well, because they're congruent chords in congruent circles, they're congruent. So FG is equal to JK, it's 80 degrees. And now we're going to try it. If the measure of arc AB is 110, then BC is also 110 because you see that those chords are both have a measure of 9. If AC is 150, find the measure of AB. Well, 360 minus AC of 150 is 210. The rest of the circle is made up of AB and BC, and they're congruent. So 210 divided by 2 is 105. If XY is congruent to YZ, then point Y and any line segment array that contains Y bisects X, Y, Z, arc X, Y, Z. If one chord is a perpendicular bisector to another chord, then the first chord is a diameter, SQ, because it bisects TR. If a diameter of a circle is perpendicular to a chord, then the diameter bisects the chord. Okay, so in this case, we're told if it's the perpendicular bisector, then the first chord is the diameter. Here we're told if the diameter is perpendicular to a chord, then it's bisecting it. And we're going to use this. 3 gardeners, 3 bushes are arranged in a garden as shown. Where would you place a sprinkler so it is the same distance from each bush? So we're going to label the bushes A, B, and C. And we're going to draw segments AB and segment BC. Now we're going to draw the perpendicular bisectors of AB and BC. We're going to go back to review how to do perpendicular bisectors, and we're going to get a compass. We're going to take our compass. We're going to put it on C, and we're going to swing this up, and I'm going to make an arc all the way around. Now, I'm going to take this, I'm going to leave the distance the same. No, I want to make the distance the same, and I'm going to make this arc. So now I have the intersections. And when we've done perpendicular bisectors, you just made up and below. We haven't made the whole larger semicircle. But in this case, it's going to be easier for me. And I'm going to take my tool, and I'm going to go through this point, and I've made the perpendicular bisector of BC. I'm going to put it on point A. I'm going to close up my compass a little bit. Yeah, actually put it back there. I'm going to rotate a little bit, close it up a little bit, and now I'm going to rotate it up here. And draw the line. Now I'm going to take this compass, I'm going to go over here, I'm going to rotate it a little bit, and I'm going to draw a line. So those got a little too close together, but I can tell those are the 2 points. So I have actually drawn 2 perpendicular bisectors. I'm going to change my color here. This is congruent to this. This is congruent to this. This is a new point. I'm going to call it D, where they meet. And they show that here. Okay. And so now, this point is going to be equidistance. If I want to check it, I can take my compass, move it over here, put it from, move this a little bit, that point to that point. And when I draw it around in a circle, it's going to go through A, B, and C. I've actually created a circle now with D at the center. A, B, and C are all on the circle. Use the diagram of E to find the length of AC. Tell what theorem you used. So diameter BD is perpendicular to AC, so this is a bisector. This is AC. If this is 7, then FC is 7. So 2 times 7 is 14. Find the measure of the indicated arc in the diagram. So this is a diameter. It bisects this chord at 90 degrees. It's perpendicular bisector. This is congruent to this. meaning their arcs are congruent. So 9x is equal to 80 minus x. I add x to both sides. I get 10x equals 80. So x is equal to 8. So this is 72. 80 minus 8 is 72. So that is the measure of each arc. Find the measure of the indicated arc in the diagram. So we just said this is 72. This is 72. So DE is 72. And CE, 72 times 2 is 144. In the same circle or in congruent circles, two chords are congruent if and only if they are equidistant from the center. So if this and this are the same length, and then they obviously intersect at 90-degree angles, because we've talked way earlier in the year about the closest distance from a point to a line is the perpendicular segment from that point to that line. So in the diagram of circle C, QR is equal to ST, which is equal to 16. And these are equal distance from each other. Okay? These are equal, then they're equidistant from the center. So 2x is equal to 5x minus 9. They've solved their x is 3. So CU, which is 2 times x, is 6. In the diagram in example 4, suppose ST is 32 and CU and CV is 12, so QR is going to be congruent to ST. It's also, now they want us to find QU. Remember, this is going to be a perpendicular bisector. So if this whole thing is 32, half of 32 is 16. Okay, this is 32, these are 12. Find the given length. Find the radius of circle C. So in order to find the radius, that's from the center to any point. So if this is 12, and we found that this is 32, so we found that this side is 16, this is our hypotenuse. So C squared equals 12 squared plus 16 squared. 12 squared is 144. 16 squared, I don't remember what that is. It's 256. So 256 plus 144 is 400. So C squared equals 400. C equals the square root of 400. So C equals 20. Find the value of x in circle C. So this is the diameter. So 5x minus 12 is equal to 3x. If I subtracted 3x from both sides, I would get 0, so I'm going to subtract 5x. I get negative 12 is equal to negative 2x. So x is equal to 6. For problem number 2, find the value of x. So this length is 4x plus 2. This length is 18. These are equidistant from C. These chords are equidistant from C, so they're equal. I subtract 2 from both sides. I get 4x is equal to 16. So x is equal to 4. Problem number 3. Determine whether RS is a diameter. It bisects a chord, okay? So yes, it bisects the chord equally. Whoops, so yes it is, okay? And here are the problems from which your homework comes.